Ooh, yeah, welcome back to Max Made Easy with AB, where Max is fun. Right, so we were discussing on functions in the previous video, and let us continue with that. But before that, if you haven't subscribed, please subscribe, please. Right, so we'll move on to types of functions. So a function is nothing but a special relation where each element in the domain have only one mapping to codomain, and we'll see some of the special types of functions here. So there are mostly spoken functions like one-to-one function, on-to function, many-to-one function, and into function, and we'll discuss each of them. The distinct element in the domain will have distinct images in the codomain, so that's actually one-to-one function. A function can be tested whether it is one-to-one or not by using an horizontal line test. One calls this function as injection 2. So let's check with an example. And here let's take f of x to be x plus 2. The horizontal line test says that the horizontal line drawn touches the curve only once. So let me draw a horizontal line here. Oh, it just touches only one point. And let me draw a horizontal line here too. It again touches only one point. So throughout the curve, the horizontal line actually touches the graph only once. So given f of x is a function. But remember, horizontal line test can be used only when the vertical line test is true. Why? Vertical line test gives you whether the given function, whether the given relation is function or not. Only when a given relation is a function, you could move on to types of function, right? So that's what I say, whenever vertical line test is passed for a given relation, then you call that as a function, and then only you can move on to the types of function. And yeah, let's see another example. Here let's define a function to be 1 comma a, 2 comma b, 3 comma d, and 4 comma c. So each element in the domain have distinct images in the codomain. So 2 is not again mapped to a. 2 has an unique image within them, and 3 has a unique image, and 4 has a unique image. So yeah, so distinct image in the domain have distinct image in the codomain, thereby making the given f to be a one-to-one function, right? So I think you would have probably known the famous WWE competition where one person fights with the other. So yeah, just when a fight occurs, one person actually fights with another one person. So that could be a best example for one-to-one function, right? So moving on to onto function, whenever the range is actually equal to codomain, then we'll call that as an onto function. Here as an example, let us consider the definition f to be mapped from the domain 1 to 3 4 and the codomain to be abc. So here the function is actually 1 comma a, 2 comma a, 3 comma b, and 4 comma c. So here we don't have distinct elements in the domain to have a distinct image in the codomain, but we look that all the elements in the codomain is being mapped by some other pre-image in the codomain. Here our whole focus is on codomain alone, right? So let's take the range of this particular function, that is the range is here abc, but look that codomain is actually equal to range. Whenever codomain equals range, then that function is called as an onto function. So let's check whether a given function is an onto function or not, right? So let's define a function f from natural number to natural number to be x plus 2. So let's check whether this is an onto function or not. So what is the main motive of onto function is that we have to check whether each and every element in the codomain have one pre-image in the domain, right? So it's likely saying let f of x be known and x be unknown, right? So given f of x equals x plus 2, we express in the form of x alone. So x equals f of x negative 2, right? So we know that the elements in the codomain 1, 2 actually does not have a pre-image in the domain. So let me say how. Let's take the value f of x to be 1 here now. So, considering the inverse here, x equals f of x is 1 here. So, 1 minus 2 is actually minus 1, which does not belong to natural numbers, right. So, f of x equals 1, that the element, that is the element in the codomain 1 does not have a pre-image. Likewise, when f of x equals 2, I have x to be 2 minus 2, which is 0, which does not belong to natural numbers, and therefore, the given function is not at all an onto function, right. That is, the elements 1, 2 in the codomain does not have any pre-image in the domain. So, given f of x is not at all an onto function, right. And let us talk about bijective function, but before that, I think you would have used WhatsApp at least once in your lifetime. So, we see that the yellow color box there, messages you send to this chat and calls are now secured with end-to-end encryption. Even the WhatsApp from Facebook does not know what is the message that you are sending, right. So, what is actually the process going on there? You type a message, then this WhatsApp actually encrypts your message. I will tell you what you mean by encryption in the next slide. So, the WhatsApp actually encrypts the message, that is, it transfers it to a secret code. Then this secret code actually reaches the receiver, and there occurs decryption in their mobile phones, and that decryption is given as a readable form, right. So, this is actually end-to-end encryption, and bijective function is one among that. So, this is called as a cipher circle. Now, let us take an example. Let us actually decode KHOOR. I will give you 5 seconds. Tick, 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 tick. Time up. I think using this cipher circle, you would have decoded this. Yes, it is actually hello, right. So, if I actually send hello in, if I actually type hello in my message and send to one of my friends, the hello is actually encrypted to KHOOR, and this KHOOR is actually received by the receiver, and this KHOOR is again decoded into hello. So, this is how WhatsApp end-to-end encryption works. Do you know what we call this at mathematics? This is called as cryptography. The process of converting one form to another form and receiving back the required information is called as bijection. This process is actually widely used in the study of secret codes called as cryptography, right. And let us see what you mean by a bijection. So, if a function f from set A to set B, which are non-empty, is both 1-to-1 and onto, then f is called as bijection from A to B. Simply saying, each element in the domain have a unique image in the codomain, and all the elements in the codomain is being mapped to one element in the domain, so that this particular case becomes a bijective function, right. Let us see many-to-one function now. If more than one element is mapped to any one element, then the function is called as a many-to-one function, right. So, we just now saw one-to-one function. So, if we want to convert this one-to-one function to many-to-one function, we need to find at least one element in the domain which is mapped to an same element in the codomain which is actually mapped by another element in the domain. For example, if we take 1 from the set A, it is actually mapped to A in the codomain, but check out 2 from A, it actually goes on, it is actually mapped to again A, which is again actually the image of 1 here. So, many elements actually go to A here. Here many means which is more than 1, right. So, this function is called as many-to-one function. Let us consider another example which is actually called as round off function, right. So, let f be a function from the positive real numbers to natural numbers. So, we round off certain values, like we round off values um, when the desired decimal place is less than 5, then the preceding number is taken, and if the number is more than 5, the succeeding number is taken, right. So 0.2 is actually mapped to 0, 0.5, 0.6, 0.9, 1.1, 1.2 is actually mapped to 1, and 1.5 and the other number here is mapped to 2, right. So this is how round off function works. So since many elements in the domain is actually mapped to same element in the codomain, that is look at 0.5, 0.6, 0.9, 1.1, 1.2. So many elements here in domain is actually mapped to 1. So this is like number of flies going into one jackfruit, right. I can't imagine a best example than this. So this is actually a many to one function. Let's think now. We just saw many to one function. Is there something called as one to many function? The answer is false. Yeah. Let's see how. Many to one function is that two or more elements in the domain is mapped to same element in the codomain. So that is called as many to one function. If one to many function is concerned, one element is mapped to many elements in the codomain, which violates the condition for a function, which violates the definition of function, so that one to many function is not at all a function. It's actually a relation, right. So I think I made this one clear. Let's look on into function now. When the range of a particular function is strictly a subset of a codomain, which is actually a proper subset of codomain, then it is called as into function. Here codomain is A, B, C, D, E, F, and the range is A, B, C, D. E and F are not at all mapped by any elements any elements in the domain, or to be simply said, E and F have no preimages in the set A, so that this makes an into function. Let's consider an example situation. Consider a teacher giving assignment to 10 students. It was said that one can either submit individually or they can combine with less than or equal to 3 students. So the number of assignments submitted can be an into function, right. So let's see how. So we have roll number 1, roll number 2, roll number 3, and up to roll number 10. So there will be many choices to map, right. 1, 2, 3 can combine with they can be combined to give one project, or each one can give their individual projects as well. But in this situation, roll number 9 and roll number 10 actually combined to give one assignment, so that the number of members in the class is 10, but the number of assignments submitted is 9. So since the range is actually a subset of codomain here, the given function is an into function, right. Even if one student combine with another student to give the assignment, then the given function becomes an into function, right. So let's summarize what we have learned in this module. So we have discussed 4 functions: one function, onto function, many to one function, and into function. Tata, bye bye, take care. This is Max Medisi with the B signing off. Bye bye.